In this video, let's do an example of how to find local extrema on our calculator. So we'll learn by doing. Here is the problem we will be attempting to find the local extrema of this function. And let's go over to our calculator. And let's see how we approach this. So this is a graphical method, first of all. So we're going to go to y equals, and we are going to enter this equation into our calculator, just as if we were going to graph it, because we are going to graph it. And now we might have to modify the viewing window. Remember that a local extrema occurs when either we stop increasing and start decreasing, or stop decreasing and start increasing. So we can see a local maximum here. We're increasing, then we're decreasing. We don't see a local minimum, but one must exist if we're decreasing here and increasing here. Well, at some point, we must have stopped decreasing and started increasing. It's currently, let me go back to this screen, it's happening somewhere down here. It's below our current viewing window. We'll press the window key, and this might require some experimentation until we get the window correct. So we went from -10 to -15. That wasn't quite it. There's a local minimum, and it's still happening just off screen. Maybe if we go down to -20, that would be enough. It is. And we need to be able to see our local extrema to find them with this calculator. So we're going to go to calc. You see it in blue up here where the tracer is. We want to calculate the minimum and calculate the maximum. Remember, this calculator is color-coded. To get to a blue thing, we press the blue button. And here we are. And we see a minimum command and a maximum command. We're gonna try to find both these things. It doesn't matter which we do first. Let's select minimum. Now our calculator is going to ask us for some stuff. You see a left bound here. So the thing is that a graph might have more than one local minimum. Like this graph has a local minimum here, and it has a local minimum here. The graph we're looking at doesn't, but our calculator doesn't know that. So to use this command on our calculator, we have to tell it where the local minimum we're looking for is. We have to tell it we're looking for the local minimum between these vertical lines. And then it will know that we're trying to find this and not this. So when you see left bound, that's what's being asked for. And in just a moment, we're going to see right bound. So back to our calculator. We're looking for this minimum, so we want to select a point to its left, and we want to select a point to its right. If we were using a fancier calculator, like I don't even remember what they're called, C plus or something, our calculator might draw a dotted line here and a dotted line here. So exactly what you see varies from addition to addition, but all of the TI-84s and all of the TI-83s work fundamentally the same. We select a left bound, we select a right bound. Now we're being asked for a guess. This doesn't really matter, but our calculator is asking us, so whereabout in this interval, whereabout between this left and this right bound do we think our minimum is? So we can scroll around with the left and the right arrows. Our minimum's about there. And now we press enter, and our calculator has found our local minimum for us, about 3.304, comma, negative 16.556. And the other extrema is going to be handled in literally, well, I can't say literally, there's one difference. We have to select maximum instead of minimum in the calculate menu. But other than that, literally the same. It's asking for a left bound. So the maximum's around here. We go to its left. Now we go to its right. Now we go to about where we think the maximum is. It's somewhere around here, so that's our guess. And we get our maximum 0.029, comma 1.004. And there's our, let me get this document camera up. Here is our solution to this question.